Hey everyone, welcome to Relative Maximum and Minimums. Okay, this is Nicholas JMV, so let's get started. We've got several examples to show you. So you've seen relative maxes and mins before on your graph, and so anytime you've seen a function being drawn and you have, let's say we have this function and you have this beautiful, let's say we have some kind of cubic like this. Well, there's going to be a maximum and minimum. And it goes on forever, so there are absolute max and mins, but we're going to be talking about the relative, the local max and mins. Okay, so if I look here, and here I can see that this is roughly going to be a maximum, this is going to be a min. And the reason we can do that is you look at this and see that is if we look at the tangent line going this way and the tangent line going this way, if we look to find the local max, which is this point right here, on your function f, find all the critical numbers where f is continuous and f prime changes from positive to negative. So a positive slope to a negative slope would ensure a local max, okay, as we move left to right. And vice versa, if you're looking at a local minimum, your slope on a continuous function f, if you go from a negative f prime to a positive f prime, you're going to show you're going to find that you have a local min. Okay, so critical numbers. Critical numbers, we've talked about this, are where f prime of x equals 0, where your slope is 0, okay, or where your function where it does not exist. So it can be either 0 or does not exist. Those are critical numbers. Okay, so that's what we need to look at. So let's go ahead and look at some examples. All right. Let's see, hopefully it goes to the next slide. Okay, so example 1, and these are all AP questions. So the graph of y equals 3x squared minus x cubed has a relative max at what point? Okay, so there's points here, so what we really need to do is we need to first find our derivative. Okay, so we're going to take y prime, and it's just a power rule, so it's not too bad. So this becomes 6x minus 3x squared. Okay, and what we want to do now is to find the critical numbers. That's when we set our derivative equal to 0, so I'm going to go ahead and do that. And what I'm also going to do is I'm going to factor out what's common. I know there's a 3x that's common, so I factor out the 3x. All right, and I'm left with 2 minus x. So when you multiply two numbers and their product is 0, we know that either 3x is going to equal 0 or 2 minus x equals 0. So our possible critical values, here are x equals 0 or x equals 2. And with this multiple choice, good, we see zeros for x's, 2's, so you can start eliminate choices. Like 1, 2 is not going to work. 4 is not one of our possible x values, so that's gone. Okay, 0, so 0, 2 are the only ones. So we're down to 3 choices now. So what I'm going to do in order to determine a max or a min, I'm going to go ahead and do a sign analysis. Okay, so here's what we do. We're going to draw our little line here, and we're going to check out these two critical values, 0 and 2. And we want to figure out what's the sign of each of these going to be. So I'm going to put 3x here and 2 minus x here. So I know that if I plug a number in for x and it's greater than 0, 3x will always be positive. So I'm going to put a plus sign here and a plus sign here. If I put a number less than 0 into 3x, my answer is always going to be negative. This is why we call it a sign analysis. Now, if I look here, any number greater than 2 will make this negative, right? Because you're subtracting more than you have. If I plug 1 in, 1 is between 0 and 2. 2 minus 1, well, any number here is positive. Okay, and any number before 0, negative, is going to make this whole thing positive. So to get the sign analysis, I multiply. So I multiply here and I go plus. Okay, and oops, that's not plus, that's going to be a minus. A negative times a positive is negative. A positive times a positive is positive, and a positive times a negative is negative. Okay, so this is what the sign of the derivative is going to be, these circled numbers. So a negative slope to a positive slope, this is a minimum. Okay, that's a minimum. And a positive slope to a negative slope is a maximum. Okay, so x equals 2 is our maximum. Okay, since f prime of 2, well, f prime of x, excuse me, changes from positive to negative. Changes from positive to negative. Okay, now we have to figure out, okay, it's not A, and it's not this part, so it's done. We've got the answer to be C. Now, if I wanted 4, all I have to do is plug 2 back into here. So if I went up here and said 3 times 2 squared minus 2 cubed, I get 4. I get 12 minus 8, which is 4. That's how you get that ordered pair. Okay, so that's about a 6-minute video. I'm going to go ahead and stop and go ahead and continue on with the next videos, but I'll break those up and make it to a few different videos. So if you have any questions or comments over this first example, just type them below, and I'll see you next time.